Okay, welcome back. Going to talk a little bit more about the unit circle. Now is when we get into a little bit of the meat and potatoes. So pay attention here and away we go. Now, I have my unit circle, okay? Now realize that I'm going to be drawing a whole bunch of lines over this unit circle, okay? There's going to be a whole bunch of lines pretty much everywhere. And they're all going to make sense in just a moment. But you know what? For right now, we're going to ignore most of that and we're going to go to the stuff that hopefully makes sense. Now, I'm going to focus on a certain part of the unit circle, much like we focus on just the unit part of a unit circle and often forget it lies within a coordinate grid. Now, I'm going to continue that problem by focusing here on just my first quadrant. Okay, and away we go. So if you remember, this is one of the special triangles here, and we kind of know this just because we've done way too much math for way too many years, and show you just what's convenient for you to know. And so here, this here is a 45 degrees. Okay, and if I draw a line, let's see if I'm interested in this point right here. This is where one of my special triangles happens. And if I draw a beautiful straight line as only I can, right down to the intersection of the x-axis, okay, and think about this. Ooh, that was extra special. This part over here, okay, you'll see that I now beautifully have a right angle triangle. Okay, this beautiful right angle triangle has a height to it. Okay, this is my y, this is my x. Okay, and especially as it relates to a 45-degree angle. Now, when a right angle triangle, you need three things. You have your x, you have your y. Hey, guess what this is? This is my r, my radius. I'm in a unit circle. Guess what the unit part of unit circle means? Well, my radius is just 1. So here, there's a few ways to explain this. And I don't know the most convenient way for us to start out with. So we're just going to start here. Okay, if I have a Pythagorean theorem, right, we have our a squared plus b squared equals c squared. Okay, if I know my a is my x and I know my b is my y and I know my c, which is my hypotenuse, is my radius, is just 1, I have that. Okay, then here, guess what? Notice how my x and my y of a 45-degree triangle, hey, look, this is also be 45 degrees. Okay, these guys are all going to be equal. Here, I might as well just call this x squared plus x squared. Okay, and then anything added to itself, hey, look, I have 2x squared equals 1. If I then solve for x, okay, by first, as we know, we're going to divide by 2, so both sides divide by 2. So here I have x squared over 2 equals 1, or sorry, x squared equals 1/2. Okay, and then the next thing, of course, is I will go through and take the square root of both sides. I end up with this x equals, and I'm just going to throw the plus minus in here for rigor, but kind of ignore that. X is equal to 1 over root 1 over 2, which, as we covered our radicals before, this is just 1 over root 2. Okay, now if I get into like the nitty gritty things, I guess I might as well. Okay, you'll cover it more later, but because you'll see it a lot. Okay, this 1 over root 2, I don't like radicals in the bottom, so I'm gonna rationalize this. I'm gonna multiply by 1, just a special version of 1 that happens to be root 2 over 2. Okay, and here I get root 2, and then root 2 times root 2 is just 2. So here I have that this is equal to plus or minus root 2 over 2. And this is normally how you're going to see this. So here I have that my x coordinate is root 2 over 2. Now guess what? As we saw before, my x coordinate was the exact same as my y coordinate. So here I have root 2 over 2. So this is weird. It's strange. Okay. But so be it. Like, get used to it, I guess, is kind of what I'm going to say is get used to it. There's not much more to it than that. But this is my first triangle here. This is my first special triangle, so recognize that at 45 degrees, my x is root 2 over 2, my y is root 2 over 2, okay? And then I have a couple more special triangles that I can use. So that was the first triangle we want to show you. The second triangle here, just so happens conveniently, because we know it's convenient, is going to be at my 30 degrees. So my 30-degree guy here is going to intersect my unit circle, gives me a convenient hypotenuse of 1. I drop down here with my beautiful straight line down to my x-axis. Hey, look, right angle triangle. Here I have a different x and a different y value. I can do all that kind of trigonometry stuff over again. I can do all that triangle stuff with all this, that, and the other thing. But the important part that falls out is that for this particular triangle, okay, if you look at this point of intersection right here, okay, my x-axis is going to be at √3/2, okay, and my y length is going to be 1/2. Hey, look at this. If I trace this right over, it goes all the way to 1/2, okay? Now, we have one other part that I just want to cover, and it's the other one that you have to memorize. And it's the other like, hey, look how convenient this is, that this is exactly what we need it to be, okay? This angle here, we're going to be at 60 degrees. I'm going to kind of think about the same trick, drop this straight down with my beautiful right angle triangle. Okay, hey, look at that. My x is at exactly 1/2. And to make it nice and easy, well, it's kind of convenient, but just easy to remember, this guy is at √3/2. Okay, now I'm going to stop this right here, and you can take a look at all that, and it can be beautiful. And in the next little part, I'm going to teach you how to memorize all three of these. It should be super easy, but only if you practice. Okay, so these are your special triangles. This is, people try to tell you all a whole bunch of crazy things about how nice it is. Okay, at the end of the day, it's just convenient, and we notice these things, and we teach you exactly these things because they're the easiest to teach and they're kind of the coolest.